Hi, it's Mr. Baker here, and today we're going to be looking at lens diagrams. Okay, so today we're going to be looking at lens diagrams, and we're going to be answering this question: how can we predict what an image will look like when we look at it through a lens? Okay, so when you're drawing a convex lens, this is what you should do. You should always draw it like this with a sort of double-headed arrow. In physics, we tend to not draw fancy drawings. We tend to draw diagrams to make sure that we always are sort of communicating about the same things. And this is the diagram for a convex lens. And for a concave lens, this is what we would draw. So a double-headed arrow, but the arrow is pointing inwards this time. So now we know how to draw the lenses. This is what a converging lens diagram might look like. So this is what we are aiming for, and I'm going to go through the different steps of how we get there. So there are some rules that we've got to follow when we're drawing these ray diagrams for lenses. So rule 1, parallel rays emerge and pass through the principal focus. So when parallel rays go through a convex lens, then they will all focus at the focal point, like that. So we can use that fact. So if we say that a ray comes off the top of the object, and it's a parallel ray of light like that to the principal axis, then that ray of light will go through the focal point. The second rule is that the center rays go straight on. So in other words, lines go straight through the center of the lens. So again, we can use this rule. We've got our first one there. The second ray will go straight through the middle of the lens. And an image made where light rays cross is called a real image. So here we've got a real image, and it's formed where the rays cross. And we can draw these with an arrow. So again, we can draw an arrow to show our object on the left-hand side, and that object can be drawn to show the size of the object, so we can draw a scale diagram. And then we can do the same for the image, and we can show the size of the image, and we can show whether it is upright or inverted. And then we've got our third rule. Rays that pass through the principal focus before the lens will emerge parallel to the principal axis. So you can see that all of these are going through the principal focus before the lens, and they're all coming out parallel. So here you can see the 3 lines that we can draw, and they will all cross at the same point, creating an image. So concave lenses are called diverging lenses, and they have a negative focal length and powers. Ray diagrams therefore need different rules. So this is a kind of diagram that we will draw when we're looking at diverging lenses. So rule 1 is that parallel rays emerge as if they originated from the left-hand focal point. Rule 2 says that center rays go straight on. And rule 3 says that rays that were converging on the right-hand focal point will emerge parallel. Okay, so let's have a look at that then. So we've got our object on the left-hand side. And what we can do is we can draw a parallel ray of light. Now we know that the light is going to diverge, it's going to change direction and spread out from this lens, and it's going to do that as if the ray of light was coming from the focal point on the left hand side. That's our first line that we can draw. The second one does this. It goes straight through the center, but the rays don't cross. But what they do is they appear to cross before the lens. So that is where our image will be formed. Our image will be formed on the left-hand side of our lens, and so actually it will be a virtual image. You can see that there isn't 2 rays of light on the left-hand side that are crossing, but it appears that one of those rays of light is coming from the left-hand side. And so it appears that the image is on the left-hand side of that lens, and so we call that a virtual image. And an image made where light rays appear to come from is called a virtual image. Okay, so this is what we've done today then. You should be able to identify the optical axis and focal point for a diagram showing image formation and the position of the image formed by a lens. You should be able to use scale diagrams to determine the size of an image produced by a lens, and you should be able to construct ray diagrams showing the formation of images by a convex lens and concave lenses and describe the properties of the image. Okay, so that's been the lesson on lens diagrams, and we asked at the beginning, how can we predict what an image will look like? Well, we can predict what an image will look like if we know how to draw ray diagrams through lenses. And hopefully through this lesson, you've got a bit of an idea about how you can do that. Okay, so that's been our lesson on lens diagrams. I've been Mr. Baker, and I'll see you next time. Thanks very much.